Today, we will be discussing quality control in the laboratory. Before we delve deeper, be sure to subscribe to Jumadeconsulting channel for a wealth of enlightening videos. Now paint this picture in your mind. A staggering 98% of medical conclusions hinge on laboratory outcomes. Absolutely, you understood correctly. Nearly all medical decisions are contingent on the precision of clinical laboratories. However, astonishingly, inaccuracies in these labs are not as you may presume. This information holds significance for those preparing for medical scientist certification examinations. Here are some example questions related to quality control that might appear on the American Medical Technologist. What is the primary purpose of quality control in a medical laboratory? A. To increase testing efficiency. B. To reduce costs associated with testing. C. To ensure the accuracy and reliability of test results. D. To meet regulatory. Answer is C. Which of the following is an example of an external quality control measure? A. Running duplicate tests on patient samples. B. Monitoring instrument calibration. C. Participating in proficiency testing programs. D. Conducting routine maintenance on laboratory equipment. Answer is C. A laboratory technician runs 10 control samples with known concentrations of a particular analyte. The results are as follows: 5.1, 5.0, 5.2, 4.9, 5.3, 5.1, 5.0, 5.2, 5.1, 5.0. What is the mean value of these results? A. 5.0, B. 5.1, C. 5.2, D. 5.3. Answer is B. In a Levy-Jennings chart, what do the control limits represent? A. The expected range of values for a particular analyte. B. The mean value of control samples. C. The allowable deviation from the mean value. D. The frequency of quality control measurements. Answer is C. Which of the following statements best describes the difference between accuracy and precision? A. Accuracy refers to how close measured values are to the true value, while precision refers to the consistency of measured values. B. Accuracy refers to the consistency of measured values, while precision refers to how close they are to the true value. C. Accuracy and precision are interchangeable terms with the same meaning. D. Accuracy and precision both refer to the reliability of test results in the laboratory. Answer is A. A control sample produces a result of 100 mg/dl with a mean value of 95 mg/dl and a standard deviation of 3 mg/dl. What is the standard deviation index (SDI) for this result? A. 1B, 2C, 3D, 5. Answer is A. If a control sample consistently produces results outside of the acceptable range, what is the appropriate course of action? A. Adjust the calibration of the instrument. B. Continue testing patient samples and ignore the control results. C. Investigate potential sources of error and take corrective action. D. Disregard the control sample and use patient samples for quality assessment. Answer is C. It's a chilly morning in February of 2023. A city hospital's clinical laboratory receives a blood sample from a patient suspected of having a rare genetic disorder. The laboratory technicians perform the necessary tests and the results are alarming. The patient is diagnosed with the disorder and immediate treatment is initiated. Fast forward to a few weeks later. The patient's condition is not improving. Doubts begin to surface. The hospital decides to send the blood sample to another laboratory for a second opinion. The results come back completely different. The patient, as it turns out, was misdiagnosed due to an error in the initial laboratory's testing process. This case study is not unique. It's a stark reminder of the crucial role that quality control plays in clinical laboratories. Without stringent quality control, errors can slip through, leading to misdiagnoses, inappropriate treatments, and even loss of lives. Certainly. Quality control, QC, in a laboratory is essential to ensure the reliability and accuracy of results generated through various analyses. It involves implementing procedures to monitor and maintain the quality of analytical processes and instruments. Here's how quality control works in a laboratory setting, along with the criteria for acceptance or rejection of analyses based on QC rules. Establishment of quality control procedures. Before any analysis begins, the laboratory establishes QC procedures tailored to the specific techniques and instruments used. These procedures typically include regular calibration of equipment, validation of methods, monitoring of environmental conditions, and verification of reagents quality. Calibration and standardization. Instruments used for analyses are regularly calibrated using certified reference materials or standards to ensure accuracy. Calibration curves or control charts are established to monitor the instrument's performance over time. Routine quality checks. Routine quality checks are conducted throughout the analysis process to detect any deviations or errors. This includes running control samples alongside test samples to ensure consistency and accuracy. Control charts and statistical analysis. Control charts such as X-bar and R charts or Levy-Jennings charts are commonly used to monitor the stability of analytical processes. Statistical analysis of control data helps identify trends, shifts, or outliers that may indicate a need for corrective action. Acceptance or rejection criteria. Based on established QC rules, acceptance or rejection of an analysis is determined. Criteria for acceptance or rejection are typically predefined and may include allowable limits for precision, accuracy, and reliability. If the analysis falls within acceptable limits, the results are considered valid. Otherwise, the analysis may be rejected and corrective actions are initiated. Corrective actions. If QC data indicate deviations or errors beyond acceptable limits, corrective actions are taken. This may involve recalibration of instruments, troubleshooting analytical procedures, or investigating potential sources of error. Documentation and record keeping. All QC activities, including calibration, control data, and corrective actions, are documented thoroughly. Accurate record keeping is essential for traceability, audit purposes, and continuous improvement of laboratory processes. Continuous improvement. Quality control processes are subject to continuous improvement through regular review and optimization. Feedback from QC data analysis, audits, and proficiency testing is used to identify areas for enhancement and implement corrective measures accordingly. In summary, quality control in a laboratory involves meticulous planning, execution, and monitoring of analytical processes to ensure the reliability and accuracy of results. Adherence to established QC procedures and criteria for acceptance or rejection of analyses is crucial for maintaining the highest standards of quality and integrity in laboratory operations. Quality control in clinical laboratories is a systematic process used to detect and correct errors, ensuring the accuracy and reliability of test results. It involves every step of the laboratory process, from the initial collection of samples to the final reporting of results. It's not just about preventing errors, but also about continuously improving the laboratory's performance. The consequences of ignoring quality control can be devastating. In the case study mentioned earlier, the patient suffered unnecessary distress and received inappropriate treatment due to a lab error. And this is just one patient. Now imagine the impact on a larger scale. But here's the good news: errors are preventable. With the right quality control measures in place, clinical laboratories can significantly reduce the risk of errors, ensuring accurate and reliable test results. This, in turn, leads to better patient care. So why is there still a lack of awareness about quality control in clinical laboratories? The answer is simple: it's often overlooked. Many people, including some medical professionals, underestimate its importance. They see it as an additional step, an extra cost, rather than a necessity. It's time to change this mindset. It's time to recognize quality control for what it truly is: a lifesaver. It's not an exaggeration to say that the future of healthcare depends on it. The world of quality control in clinical laboratories is vast and complex. It's a field that requires continuous learning and improvement. And it's a field that everyone, especially medical professionals, should familiarize themselves with. So think about it. Delve deeper into this subject. Learn more about quality control in clinical laboratories. Understand its importance, because knowledge is power. And in this case, it's the power to save lives. Remember, 98% of medical decisions are based on laboratory results. That's a huge responsibility. And with great responsibility comes the need for great quality control. Because in the world of healthcare, there's no room for errors. As we draw towards the end of this enlightening journey through the importance of quality control in clinical laboratories, we hope you found this video informative and helpful. Knowledge is power, and sharing it can save lives. So if you found this video useful, don't hesitate to subscribe for more informative videos and share it with others who might find it beneficial. Remember, by staying informed, we stay safe. Don't forget to hit the subscribe button and share this video. Let's continue to learn and grow together.